this discussion. So this is the second video, though we already have our discussions in our face-to-face, but for the sake of those who are pure online, so please watch this discussion. Okay, so let's have a review of relations and functions. Here's the list of the domain in the range of each relation. So we're going to determine if the relation is a function or not. So we have letter A and letter B. Letter A, we have an example 2 and 1, negative 3 and 4, and 0 and 5. And 1 and 3, negative 2 and 4, 3 and negative 2, and negative 2 and 7. An example letter B. Okay, before we go through with these examples, we have here some note. Note 1. Remember that a relation is a correspondence between two sets that each member of the first set corresponds to one or more members of the second set. And remember that the domain is the first set and the range is the second set. And as we said before, that the domain is the x values and the range would be representing the y values. Another thing is that every function is a relation, but not every relationship is a function. Okay, and take note of this. Many to one correspondence and one to one correspondence are functions, while one to many is not. So let's analyze the example. So let's have letter A. Okay, let's have a mapping representation of this. So what are the domain of these um, relations? We have 2, we have negative 3, and 0. Of course, we have to arrange that in chronological order when we are talking about the mapping. It could be a descending or ascending order. So let's try to have the ascending order. So negative 3. So this is the domain. What comes next? 0. Okay. 0 and then 2. So this would be the domain, or let's say this is the x. Next, let's have the range. We have the range 1, 4, and then 5. So we have the lowest one. We have 1, 4, and then 5. Okay, so this is the y values. Let's connect the pairing. So negative 3 pair with 4, and 0 corresponds to 1, and the input of 2 is, what is the input of 2? Let's have 0, I'm sorry, it should be 0 and 5. Okay, so negative 3 and 0. Sorry. Okay, so negative 3 and 4, and then 0 and, sorry, 0 and 5, and 2 and 1. So let's erase this one. Do not be confused on. Okay, negative 3 and 4. Okay, so what can you say about this representation? So 3 is only assigned 4, and 0 is only assigned 5, and 2 is only assigned to 1, meaning that this is a one-to-one correspondence. So ibig sabihin, this is F functions. Okay? So let's move on to letter B. What about letter B? Is that a function or not a function? Let's use again the mapping. So let's identify the domain. We have 1, negative 2, 3, and negative 2. So this time we're going to use descending. So we have negative 2. And what comes next? We have 1, domain 1. And next would be -2. There are two. Okay, we have -2. We have okay, 3. Sorry, this is supposed to be 3. Okay, let's check. The lowest one is a -2. As you can see in here, we have, this one, -2, and then -2. Okay, if there are two numbers in here, it is not necessarily to put it -2 in here. So just copy one in the mapping representation. So the next is we have 3. Okay, we write it. 3, and we have 1. So these are the domain of these relations. Next, what about the range? Okay, we have 7. What comes next? 7, and then 4. We have 4, and then 3. And the next one is -2. Let's connect the domain to range. So -2 paired with, okay, let's see this one, -2 and 4. Okay, -2 and 4, and then -2 and 7. So 2 and 7, and then 1 paired with 3, okay, that one, and then 3 and -2. So what is this? Is this a function or not? Right? It's definitely not a function. Why? Because of this rule. Okay, the domain, the x value has only one output in the range. So one to many is not a function. So this one, so it has to output. So this is not a function. Okay. So take note of this. So that's the review about the relations and functions. And let's move on to our next discussion, focusing on functions. Okay, I'm not going to read everything in here, but to outline what this tells us. So functions is a special type of relation between two variables. Okay, what are these variables? We have the dependent variable and we have the independent variable. Okay, so what is the independent variables? The independent variables are quantities that change its values based on natural phenomena. So that's the independent. Dependent variables, on the other hand, the quantities that change its values by changing the magnitude of the independent variables. So we're going to get through this through our example next or on our next slide. And relation is possible or is being formed if the if one variable is associated with another variable, or the dependent variables is associated with the independent variables. Okay, so that's the functions. Okay, again, function is a relation between dependent and independent variables. Wherein for every value of the independent variable where the function is defined, there exists a unique and a single value of dependent variable. Okay, so take note of this single value of the dependent variables. So let's have this in our example. Now, we have some ways of representing the function. Okay, so in this illustration, it says here that let x be the first variable, and the independent variable would be y, would be the second variable. Okay, so meaning that x is the independent variable and y is the dependent variable. Okay, take note of this. X is the independent variables, y is the dependent variables. And y in a function, okay, we're going to read that, or that is equal to f of x, right? Y is equal to f of x. That's why, as you can see, that f of x replace the variable y. So it says here that the different ways of writing y is equal to f of x, that is, read as y as function of x, right? To make it equation. So the different ways of expressing f of x being read as f of x are as follows. We have in ordered pairs. So as you can see, x, f of x, instead of writing the y because of following the equation. Okay, so next we have equation. Equation y is equal to f of x. Okay, um, the next is we have table. When it comes to the table, of course, we knew the ordered pairs. That is in a tabular form using the two rows. And we have mapping. Okay, the map we used that a while ago. The mapping in the tabular form representing the functions. Okay, the values of x and the values of y. And of course, the graph. What is the graph? This is actually the practical ways of representing the function, where the properties of the function can be fully identified and discussed. And of course, by seeing the direction of the graph, you can say that this is a function or not. Okay, those are the ways of representing a function. So let's move on to our example. So here is